Welcome to Spring Lib.
Here we are first going to apply the conservation of linear momentum to the collision between the stick and the pan. And then we are going to use the conservation of energy to the motion of the collision to find the amplitude by the resultant SHM. So, to find out the speed of the stick, that is, speed of stick before collision, this is what we have to find. The first case. So let us consider that to be Vy. So for that, we are taking a coordinate system where plus y is downward. Now, V naught y equal to 0. Why? Because it is released from the rest. And we have been given y minus y naught equal to 0.40 meter. And the acceleration equal to plus 9.8 meter per second square. We have to find out Vy. So this is the A part. So we have Vy square equal to V naught y square plus 2ay into y minus y naught. We have been given all the values here. So Vy equal to plus 2ay y minus y naught. When we are putting all the values that is given to us, that is equal to plus of root 2 into 9.80 into 0.40, which is equal to plus 2.80 meter per second. So now we are going to apply the conservation of momentum to the collision between the stick and the pan. Now when we see after the collision, the stick and the pan has a common velocity, which is V2. Now let us consider A to be the stick and B to be the pan. So the conditions of motion before and after collision can be shown diagrammatically in the following way. Because we have considered plus y to be downward, we are drawing it in this way. These are the two cases. X, Y. This is before collision, it has not collided yet. Here this is the stick and this is the pan. Now here this is after collision. Here there is a VA1 which is downwards and which we have found it out to be Vy. That is 2.80 meter per second. And VB1 equal to 0 because it is again at rest. This is before. This is after. Now, because now it has touched, it will have a common velocity V2. That is what we have to find out. So let's see how we are going to proceed with it. So we know, according to the conservation of linear momentum, Py is conserved. What do you mean by that? MA1 VA1y plus MV V1y equal to MA plus MB into V2y. From this we can understand that MA VA1 equal to MA plus MB into V2. From this we get V2, that is MA upon MA plus MB. Cross multiplying itself, nothing else. VA1, just put the values 2.2 kg divided by 2.2 plus 0.20 into 2.80. So after calculation, we are getting the value to be 2.57 meter per second. So this is the common velocity of the stick and the pan after collision that we get. So now let's move to the second part of it. B part. The conservation of energy is applied to the SHM. Conservation of energy. So when that is applied, you will get half mv naught square plus half kx naught square equal to half ka square, where v naught and x naught are the initial speeds. They are the initial speeds. And displacement of the object, and where the displacement is measured from the equilibrium position of the object. This is the consideration that we have taken. So the weight of the stick will stretch the spring an additional distance d, which is given by kd equal to mg because of the weight of the stick. Hence, d equal to mg upon k, which is equals to 2.2 into 9.80 upon 400 Newton per meter, which is equals to 0.0539 meter. Because of the weight of the stick, this much distance is more stretched. So just after the stick hits the pan, before the pan has had time to move, the stick plus pan is 0.0539 meter above the equilibrium position of the combined object. Thus, now x naught we can put it as 0.0539 meter. Now from part A we have got v naught equal to 2.57 meter per second. The speed of the combined object just after the collision, or the V2 you can take. But in this case, we are taking as V0. Then half mv0 square plus half kx0 square equal to half ka square. It gives A to B. That is the amplitude. mv0 square plus kx0 square upon k. Putting the values of all the variables that we have, A will be equal to root of 2.4 into 2.57 meter per second, the whole square plus mv square it is, right? So 400 Newton per meter into 0.0539 meter per second, the whole square upon this k, that is 400. After calculation, we are going to get it as 0.21 meter. So this is the amplitude. This is the amplitude that we require, that is A. Now, in the C part, we are going to find out the time period. We know the formula to be 2 pi root of m upon k. That is equals to 2 pi root of 2.4 upon 400 Newton per meter, which is equal to 0.49 seconds. So this is the time period. So the amplitude is less than the initial height of the stick above the pan because mechanical energy is lost in the inelastic collision.